Alright, the next example is suppose that we were having children. And again, having children, we're going to assume that having boys and girls are equally likely. So this is a lot like the flipping the coin example. And I'm going to set it up in a very similar way. Now, I suppose that a couple plans to have 3 children. Again, the probability of having a boy and a girl is the same. Right? There's the probability of having a girl is 1 out of 2. Probability of having a boy is 1 out of 2. Alright, so again, there are 2 possible outcomes. Alright, so we have child 1, child 2, child 3, and then all outcomes. Well, there are 2 possibilities in each of these. There's 2 for the first child, 2 for the second, 2 for the third, so it'd be 2 times 2 times 2, and so there are 8 total outcomes. I have 2 chances for the first child, 2 chances, boy or girl, right? Boy or girl. For the second, boy or girl for the third. Now, again, if we want to list them, I'm going to use a tree to list them. So each branch is going to represent each child. So I'm going to start down here, child 1, there's 2 possibilities, right? And I'm going to let B be a boy and G be a girl. All right, so my first set of branches will just be those 2 outcomes. Boy, girl. Then we draw a set of branches out for the next child. And again, we branch out twice again on both of those because the second child also could be a boy, girl, boy, girl. And then the third set, we again branch out on each of those. Because again, boy, girl, all the way down my list. And if you count that last set of branches, you'll count. It ends, there are 8 of them. There are 8 ending points. 1, 2, 3, 4, 5, 6, 7, 8. And so then the list, you read down the branches. So one possibility is all boys, right? Boys on the first, boys on the second, boys on the third. And then you read down the next set of branches. Boys, boy, girl, boy, girl, boy, boy, girl, girl. All right, and those are all the possibilities when the boy is first, right? Coming from the first set of branches. There are 4 outcomes when the boy is first. And then you get 4 outcomes when the girl is first. And so again, you read down the branches. So girl, boy, boy, girl, boy, girl, 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 boy, and then all girls. And if you count them out, there are 8 total outcomes. All right, depending on which order you have the child in. The order matters, right? Because it's different if you have a boy first, right? The boy is the eldest versus the girl is the eldest, right? So again, there are the 8 possible outcomes. Once we know that, then it's a little easier to answer the questions. All right, so find the probability of having a family of all girls. Well, all girls was the very last outcome, right? Was 1 shot out of 8. 1 out of 8. Which is 0.125 or 12.5%. More girls than boys. So this one you have to be a little careful of. You want more girls than boys. And so more girls would mean the outcomes where you get all girls, right? If you have all girls, you've got more girls than boys. Or 2 girls and 1 boy, right? And that's it, because if I go any further than that, I would get 1 girl and 2 boys, and then boys would have more. And so all of the outcomes where I have more girls than boys would be all the girls case, or 2 girls and 1 boy. And remember, there are more than one ways to do that, because they're different orders. So if you go look at the different orders, you can count them there, or you can maybe just think it out. I could have a girl, girl, then boy, girl, girl, boy, girl, girl, and those would be all the outcomes where I've got 2 girls and 1 boy. And so there is a total of 4 outcomes, right, where I've got more girls than boys. And so if I'm looking for the probability, well, there were 4 ways to get more girls than boys out of my 8 total outcomes. So that reduces down to 1/2, 0.5, or you have a 50% chance. And again, it should make sense. You have a 50% chance of getting more girls than boys. Flip that over. If I ask the other question, what's the chance of getting more boys than girls? Well, you would also have a 50% chance. I didn't ask it in here, but I'm going to just add one sort of to this. What if you want at least 1 boy? At least 1 boy. Well, that means 1 boy or more. one boy or more. And we're going to find a different way to do this in a little bit, sort of foreshadowing. All right, so one boy or more. So it means I get one boy, which means I would have two girls. Or two boys, which means I had one girl. Or all three come out boys, right? At least one boy. And so I go figure out, basically you're throwing out the one outcome with all girls. And so if you count up all the ways that happens, so if I go up here and look here, basically that would be all of these, right? I get at least one boy. If you look, there's at least one B in all of those. And so that would be all but that one outcome with all girls. So that would be 7 chances out of 8. So 7 out of 8 would be the probability in that case. And we're going to talk about this at least in a little more detail later on. There's actually an alternative way that we can do the at least. All right, but again, that's sort of foreshadowing that example. All right, so I'm going to stop there. That's the having a child, different boy or girl. The next example I'm going to pick up in the next video.